Alright, in this video we're going to talk about solving quadratic equations using the quadratic formula. In previous lectures you've heard us talk about solving a quadratic equation using factoring, using the square roots property, using completing the square, and now this method is one of the most practical methods that you can use if a quadratic equation is not factorable. The quadratic formula. If your quadratic equation is in the standard form we've talked about previously, ax squared plus bx plus c equal to 0, where a, b, and c are the coefficients of the terms. A is the coefficient of your x squared, b is the coefficient of your linear term x, c is the constant. Then you can solve any quadratic equation using the quadratic formula. X equals the opposite of b. Some people read this as negative b. This actually means the opposite of b, plus or minus the square root of b squared minus 4 times a times c, and then that's all divided by 2 times a. So it's just going to be plugging the numbers a, b, and c from your equation into this specific formula, and then we're going to simplify the formula down. Now there's a little song you can sing that helps you memorize the quadratic formula. It's to the tune of Pop Goes the Weasel, the little kid song that you might have heard in your past. But I'm going to sing it to you to help you kind of memorize this formula. This is a formula that you will need to memorize to be able to use over and over throughout the course. So to sing this little song is to the tune of Pop Goes the Weasel. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you can sing that with me. We'll do it one more time just so you kind of understand how that flows. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And it's very important that you know that that is all over, it's all being divided by the 2a. So let's use this formula to solve a quadratic equation. So in this one we have this quadratic equation in standard form. In this case, my a would equal 1. The coefficient of your x squared is 1. The b would equal 4. And the constant c is equal to negative 1. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So plugging our numbers in and working this out, x equals the opposite of b, or negative b, so negative 4 plus or minus the square root of b squared would be 16 minus 4 times 1 times negative 1 all over 2 times 1. So I'm going to take that up and we're going to work that out a little bit further. So x equals negative 4 plus or minus the square root of. Now if I work the stuff out correctly with the order of operations underneath the radical, I have 16. Then this is all multiplied together. So negative 4 times 1 times negative 1, that's going to be in positive because of the two negatives. So we're going to actually add 4. 16 plus 4 all over 2. So negative 4 plus or minus the square root of 20 all divided by 2. Simplify your radical expression. So to simplify the square root of 20, we could break that into 4 times 5. So that would come out as 2 square roots of 5. And that's all divided by 2. Now as you can tell, since we're dividing the whole thing by 2, I can actually divide 2 out of the negative 4 and 2 out of the leading coefficient 2 here. So my simplified answer would be x equals negative 2 plus or minus, 2 goes into 2 one time, so we'll just get the square root of 5. So if we separate our answers out, x would equal negative 2 plus the square root of 5 and negative 2 minus the square root of 5. Let's try another one. X equals the opposite of b. So 5 is what's b in this case. So negative 5 plus or minus the square root of b squared. So that's going to be 25 minus 4 times 2, which is a, times c, which would be negative 2 in this case, all over 2a, so 2 times 2 in this problem. Simplify the expression. Negative 5 plus or minus the square root. So I have 25. Again, I have two negatives being multiplied, so it's going to be plus 4 times 2 times 2. That would be 16 all over 4. So x equals negative 5 plus or minus the square root of 25 plus 16 is 41 over 4. Now, in this problem, the square root of 41, I can't simplify that square root. That's as far as we can go. So my answer will just be what we have written here. Now we can separate that out. You could say negative 5 plus the square root of 41 divided by 4. And then negative 5 minus the square root of 41 divided by 4. All right. This problem, in this one, we have the equation not in standard form. Before I can plug it into the quadratic formula, I have to have it equal to 0. So in this case, I need to move the 3 back over to the left side. So 6x squared minus 4x minus 3. So I'm just going to subtract that 3 back over to the left side. So now I have a being 6, b equal to negative 4, and c equal to negative 3. So x equals the opposite of b, so it's 4, plus or minus the square root of b squared, so that's going to always be positive. When I square something, it should always be positive, minus 4 times a, which is 6, and c is negative 3 in this problem, all over 2 times a, so 2 times 6. So x equals 4 plus or minus, again we're going to have an addition under the radical, so 16 plus 24 times 3, that's going to be what, 72, so all over 12. So let's follow up here and finish our steps up here. X equals 4 plus or minus the square root of 88 over 12. Now the square root of 88 can be simplified. 4 times 22, so we'll have 2 square roots of 22 over 12. Now this problem can be reduced down to lower terms because the 4, 2, and 12 have a common factor of 2. So I'm going to take a 2 out of all those to reduce this. So that gives me 2 plus or minus the square root of 22 all over 6. Now, if we were going to separate this out, we could have 2 plus the square root of 22 over 6 and 2 minus the square root of 22 over 6. Okay, this is another example. It's in standard form, but there's one thing that we don't like with this, that negative leading coefficient. Now you could plug it in just this way into the quadratic formula and work it out, and it would be fine. But it's also an equation, so if I change the sign of everything, that is a legal move. So I can say that this is 2x squared minus 6x plus 5 equal to 0. That's the same equation. I've just multiplied through by a negative to get that leading coefficient to be positive. So let's plug into the quadratic formula. X equals the opposite of b, so positive 6, plus or minus the square root of b squared, so that's going to be 36, minus 4 times 2 times 5, all over 2a, so 2 times 2 in this problem. So let's see how this cleans up. You got 6 plus or minus the square root of 36. Now I only have one minus sign this time, so it is going to be a subtraction. Minus 4 times 2 times 5, that's going to be minus 40 all over 4. So 6 plus or minus 36 minus 40 is negative 4. So we have a negative under the radical, which means we're going to factor the imaginary unit out. We're going to factor the I out front. So x will equal 6 plus or minus. The square root of 4 is actually 2, so this is going to simplify to 2i over 4. Now, I can reduce this one down to lower terms because the 6, 2, and 4 are all divisible by 2. I can divide that out. So that gives me 3 plus or minus I over 2. Now, if you're going to separate your answers out on this problem, you would actually say 3 halves plus 1/2 I, and then 3 halves minus 1/2 I to have your numbers in their complex form. So that is like 3 or 4 examples of just how to use the quadratic formula. It's a very handy tool. You will use it several times in algebra and up higher math courses. This last slide is just to give us a summary of methods we use to solve a quadratic equation. Remember, a quadratic equation is an equation where your highest power is 2, the second degree. So factoring is always great, and it's usually fastest, but if it doesn't factor, you of course can't use that method. Square root property, it's a simple method, but you have to have a specific form of your equation before it'll work. You've got to have a perfect square equal to a number. Completing the square is an okay method. It is usually not the best method. It will work. It can always be used, but sometimes the steps are just there are so many steps to do. People usually forget some of those steps, so it's maybe not the best way. Quadratic formula is great because it can be used on any quadratic equation, and if you can't factor it, I say